And then when we started talking about the idea of data, we realized that there's a lot of different type of data that we can actually get. For example, age and height, those are things like numbers that we can be given. We mentioned like your occupation or your gender or your political affiliation. Those can be answered using words, so like usually a one-word answer. There's also like yes or no, true or false, free response questions that are all very different types of data that we can get. Now in statistics, we always like to put things into categories, and that's what we're going to do today. We're going to learn about all the different types of data, how we can describe them, and then we'll use those words later on in the semester to talk about like how we represent it and how we calculate things with different types of data. So if we flip to the next page, we have this awesome little chart here. And there's two main types of data, and within those two types, there's other types of data. So I think this chart really separates out like all the different things that we can see when we're looking at types of data. Now, biggest type of data are two types. The first one I'm going to throw at you is called qualitative. So qualitative data. Okay. Qualitative data is described in the name. When you ask for the quality of something, do you usually respond with a number or a word? A word, right? The quality of this chair is good, right? It's not 3 or 7 or 15, right? So the whole idea behind qualitative data is it's a verbal sort of data, okay? So you always answer in words, okay? On the other hand, we have quantitative data, right? So the quantity of something is how many things are. So quantitative. These are numerical types of data. So when you ask a quantitative question, you get a number as an answer. Okay. So those two aren't too bad, right? Words versus numbers. But within each type of category, there's two different types of ways that we can represent things. So let's focus on qualitative first, okay? Qualitative data, words, right? And there's many different types of words. The way that we're going to separate these types of words is this way, okay? The first type of qualitative data that we're going to talk about are ordinal data, okay? And ordinal data represents data that can be put in some sort of natural order, okay? So let me write that out. Can be placed in a natural order. Okay, so there's some way we can say something is less than or smaller than or greater than the other. Let me give you an example. An example of ordinal data would be, for example, let's say book quality. Book. Okay, now, for example, when you are college students, so I'm sure that you have gone to the bookstore and looked at all the expensive books there. I recommend not going to the bookstore to buy your books. A lot of times you can find used books on Amazon, right? And Amazon books are a lot cheaper than the ones you can find in the bookstore. Now, when you're looking at the used books, there's also a quality attached to them. So it'll say good or excellent or bad. And that describes like how many holes are in the books or is there writing on the books and things like that. If something's excellent quality, it's probably new. And if it says bad, it's probably like fallen off the spine, right? So book quality, like bad, good, excellent. These ways you can respond to book quality have a very natural order. Bad is definitely not as good as good, and good is definitely less than excellent, right? So this can be put in a natural order. All right. Next, we have the idea of nominal data. Nominal is the opposite of ordinal. So nominal data can't be put in some natural order. There's no natural way to say something's less than the other or something's smaller than the other or something like that. An example of this is eye color. Okay, now there's all different types of eye colors, right? There's brown, there's blue, there's green, but there's no like natural set way to say that like green eyes are better than blue eyes and brown eyes are better than green eyes, right? There's no natural way to say that one is smaller than, less than, something like that with eye color. Okay, so I would say that would be nominal. Now, In every class, I usually get a comment about like Nazis and how they did that. That wasn't normal, right? That wasn't a natural thing. That was more of like one person saying that was the best thing. So I'd say eye color is definitely nominal, right? There's no natural order for this. Okay. Any questions on the type of qualitative data? All right, let's move on to quantitative data. These are the ones that can be expressed using numbers, right? So any sort of number is qualitative. There's two types of numbers that we can talk about. The first one, discrete. Discrete, don't confuse this with the actual word discrete, like don't say anything, be discreet about it. Discrete actually comes from this Latin word that means separate, okay? So discrete describes numbers that are separate from each other, things that you can count, like 1, 2, 3, 4, 5, things like that, okay? Now, I think the best example that is really famous for being discrete is the number of children you have. Okay, there's this famous kind of morbid advertisement that I saw. I think it was like for Toyota or something. And it said the average number of children people have is 2.3. And then it has like a picture of like a kid not wearing a seatbelt. It was kind of morbid. You can't have 0.3 of a child, right? You can only have 1, 2, 3, 4 children, right? So I would say the number of children you have is discrete. You can't have a decimal or a fraction of a child. You can only have a counting number. All right, the opposite of discrete is continuous. And continuous data goes, it has a continuity to it. There's a range of different values. So an answer to a continuous type of question might be like 1.757264, right? Something that can be expressed using one of these decimals. Okay, an example of continuous data would be maybe like the height of a bug, right? So if you look at a bug and you want to measure how tall it is, it could be like 1.2 centimeters or 0.8 centimeters tall, right? It doesn't have to be 1 centimeter, 2 centimeters, 3 centimeters tall. Now, I will say on the homework and on tests and quizzes, tell me the difference between ordinal, nominal, discrete, continuous. They can be a little bit overlapping. I don't even know if that's a word, but sometimes there really is no right answer. What really matters is how you describe why something's ordinal or why something's nominal, why something's discrete or why something's continuous. Some of these can be either of them depending on how you're thinking of what they are. And we'll see how that goes when we look at some examples. All right, let's go down here. I have some examples over here. So we have some things that we need to decide what type of data that they are. So get out your cards, your yellow card and your blue card. Okay, we'll do a little game, which is literally just holding up your cards. Okay, let's say this. Are you all right over there? Okay, all right. Anyone with a, oh no. Okay, give me 1 second. I saw a bunch of blue, so hold on to that thought real quick. Let's do this. Okay, I saw a lot of blue cards. Anyone with a blue card want to explain why your major is qualitative? Yeah, your major is not a number. If someone's like, oh, what's your major? You're not going to be like, my major is 7, right? That's not a major. So because you can describe that using words, I would say this is qualitative. I'm just going to write qual. All right, number of people living in your hometown, blue or yellow? Lots of yellow. Anyone with yellow want to explain? It's a number, right? The number of people, it literally says number in it, right? So that's got to be quantitative. All right, I think I'll stop asking people to explain. Blue or yellow, the street you live on? Lots of blue, right? Because the street you live on is a word, right? Usually the name of a street is a word. So I'm going to say qual. What about the height of a plane in feet? Lots of yellow, right? Height is a number, right? So that's going to be something that's quantitative. Okay, I think that telling the difference between qualitative and quantitative is pretty cut and dry. I think those questions are pretty easy. It gets a little bit harder when we move into the next type of data here. Okay, let's do blue for ordinal and let's do yellow for nominal. Remember, ordinal are things that can be put in a natural ordering. Sweatpant size. Who thinks blue for ordinal, yellow for nominal? Lots of blue. Anyone with the blue want to explain? Jason? Yeah, right. Small is definitely like a smaller size than medium. Medium is definitely a smaller size than large, right? So this would definitely be something that I would put in order. I would say this is ordinal. All right, let's do movie genre. Blue or yellow? Lots of yellow. Anyone want to explain why it's yellow? Yeah, right. Like a person can have a preference. Like I like horror movies better than action movies, but there's no like set, like definite thing. Like action is better than horror and horror is better than comedy, right? So I would definitely say that this is nominal. All right. By the way, the ordinal, it doesn't always have to be better than, right? It could just be a natural order like size or something like that. So I do get a lot of questions as to like, oh, does ordinal mean better than? No, it just means that you can put them in order. All right, education level, blue or yellow? Lots of blue. Anyone want to explain why it's blue?
Because the elementary school is less than middle school, and you go to high school and you go to college, and you can't really skip that.
Yeah, right. You can kind of order them in like, oh, when do you do one first, right? Usually you don't go from high school to grad school, right? You have to do high school, college, then grad school, right? So there's some sort of natural ordering as to like, oh, when does this happen in someone's life? Or what order would you do this in? So this is definitely ordinal. All right. Let's go to discrete and continuous, but you know, let's do blue for discrete. Let's do yellow for continuous. Okay, let's do, I don't know, a student's grade level. Okay, who says, well, do blue and yellow. All right, I see actually a mix, which is interesting. Anyone with a blue, so discrete, who wants to explain that one? That's true. That's kind of what I was thinking. Anyone with yellow want to explain? I saw some yellow cards, and I think you have a point. All right. I got an explanation for yellow last time, which is like, well, you can kind of be a sophomore and a seventh, right? Yeah, you can be. So if you explain it as an, oh, well, you can be like in 3.7th grade, I guess it counts as continuous, but I think most people would say a grade level is discrete, right? So you can be in 3rd grade or 4th grade, and I cannot spell discrete. Go. But most people don't say, oh, I'm 10.75 grade, right? All right. Let's do time for a text to be delivered, blue or yellow? Lots of yellows. Anyone want to explain why it's yellow? Ange? Oh, I thought you had your hand up.
It has an hour, then it has a minute. I guess it's at a specific time, but it's like.
Yeah, perfect, right? There's milliseconds. There's even things that are further than milliseconds, and I cannot think of it on the spot here. But even if we went with just seconds, the time it takes for a text to be delivered could be like 1.7526 seconds, right? So it doesn't have to be like 1 minute or 2 seconds or 3 seconds or something like that. You can have a decimal as a time for a text to be delivered. So I would definitely say that this is continuous. Okay. Last one, what's the number of dogs adopted last month? Blue or yellow? All right, lots of blues. All right, anyone want to explain why it's blue? Elizabeth? Yeah, right. You can't adopt half a dog. That would be kind of sad, right? All right, I got a question in my last class. They were like, what if the dog doesn't have a leg? I guess that would count, but most of the time people describe the number of dogs you adopt as like a discrete number, right? That'd be so sad if you're like, oh, I adopted like 0.75 of a dog yesterday. It's so fun. That would be so sad, right?
You could also say that half a child.
Yeah, you could be like, oh yeah, I have 0.99 of a child. That's so mean. I am 0.99 of a person because I'm missing some brain cells. All right, let's continue on. All right, let's start this new section. Let's go away from types of data. By the way, are there any questions about types of data? All right. Let's talk about bias in studies. All right, so moving away from all these definitions, let's talk about my favorite section to talk about, which is all this deception that can happen in your life that you might not even know is happening. And let me try to explain that further. Okay, so first of all, whenever you deal with anything and you're going into future careers, you're probably going to be doing one of these three things, if not all of them. The first thing you may be doing is going out and collecting data. A lot of people go out and do that for their career. The second thing, which I see a lot of, is displaying data, like creating charts and graphs and visuals to describe what the data looks like. The third thing that you'll see a lot in jobs and things like that is summarizing data. So taking all this data and compiling it into like one number that represents the entire data set. So whatever job you have, you're probably going to be doing one of these three things. And even if you're not doing one of these three things, you're constantly being shown data in your everyday life. Billboards, magazines, even like social media, you're going to see a lot of these graphs that display data in a way that might be deceptive, and you might not even know that it's being deceptive. And I'll show you some examples, and some of them are easy to understand, and some of them are like kind of weird and hard to figure out if they're actually being deceptive. But let me show you some examples. All right, here are two graphs. They show the interest rates of this company, or not of this company, interest rates in general. The graph on the left looks like it's going up. The graph on the right looks like it's about steady. What if I told you that these two graphs come from the same data set? So same data, they're just represented different ways. What's the difference between these two graphs? Noah?
One's way too big for the percentage to really show the difference.
Yeah, so I think you're looking at the y-axis, right? If you look at the y-axis or the vertical axis on the right graph, it looks like it's going up by about 0.5%, right? If you look at the one on the left, this is going up by a much smaller value, like 0.002, right? And the way this person who made this graph did this is take a look at where it starts. On the right, we start with 0, like every graph normally does. On the left, this graph actually just starts from 3.14. It doesn't start at 0. The technical term for this is a truncated y-axis. Basically, people do it to exaggerate the differences between bars in a graph. And it's actually pretty useful to see the difference here. So on the left, it definitely looks like the graph is going up. If you decide to start the graph at 0, looks like the interest rates are pretty stable. Okay, let's do something that's a little bit more deceptive. Let's go to these two graphs. This is the annual revenue. The graph on the left is going up. The graph on the right is going down. What if I told you that these were the same data set? What's the difference between these two graphs? How can one go up and the other one go down? This one's a little tricky. Alan.
One of the left says even the annual revenue, the other one is just annual revenue.
Ooh, okay. So Alex says, Look at this. The graph on the left says the word cumulative. What does cumulative mean? Like it, I think you said adds up. Yeah, for example, the final exam for this class is going to be a cumulative final, which means it's not just a regular exam, it includes everything that comes before it. Let me show you, I think this explains it a little bit better. Let's say we have data, and in January, I'm doing small numbers because I can't add very well. Let's say in January you made $3, and in February you made $4, in March you made $2, and in April you made $1. Okay, let me show you what the cumulative data would be. So cumulative data. Okay, cumulative data in January you would still have $3. What would the cumulative data for February be? 7, right? Because what you're going to do is you're going to take 4, but add everything that came before it. So it's literally 4 plus 3 makes the cumulative data 7. What would be the cumulative data for March? 9, right? Because it'd be 2 plus 4 plus 3. And then for April, it'd be 10, right? Because it'd be 1 plus 2 plus 4 plus 3. So if all the data values are positive, is the cumulative graph ever going to go down? No, right? The cumulative graph never goes down. It always has to go up. So the person who made this graph probably saw that the company's annual revenue was going down, but they didn't want to show that to people. That looks really bad. So they'll just make the cumulative annual revenue and it looks really good, right? It's going up. So this is what a lot of people do to make it seem like their company's doing really well, even though their company's actually not doing very well at all. It looks good, but it's presented differently. All right. Any questions on this graph? All right. Let's go to this one. This one's a little bit more morbid here. Here we're looking at the gun deaths in Florida after this law was passed. So after this law, looks like the gun deaths have gone down. Looks like this law did a great job. Okay. You don't see anything wrong with this graph? I'll give you a hint. After the law was enacted, the gun deaths are not actually going down. And
Isn't it because like if they shade at the top and then it makes it look like it's kind of upside down?
that's true. I think you're getting at it. So you're saying it's upside down, and where does the graph start? At the top, right? So look at the y-axis here, okay? Most graphs start with 0 at the bottom, and as you increase, you get bigger, right? Here, 0 is at the very top of the graph, and we're increasing as we're going down. So this graph is essentially just flipped upside down. So if you wanted to read it, you'd actually have to like do a handstand and read it upside down. So even though it looks like after this law, the gun deaths are going down, it's actually going up because the graph is upside down. Okay, so this graph is a little bit more deceptive and trying to show you one thing when it's actually something else. All right, let's do another one. This is a little bit more famous. This is an example of something called correlation. So correlation. Okay, correlation happens when you put two sets of data, like two graphs on top of each other, and it looks like they follow the same pattern. Okay, so it looks like, if you look at this graph, gee, thanks, Nick Cage. Looks like you made people drown by falling in a pool based on how many films that you've hidden, right? Well, the thing about correlation is it doesn't imply this thing that we'll talk later about called causation. Okay, just because two things follow the same pattern doesn't necessarily mean that Nick Cage is making people drown by falling into a pool, right? So just because two things look like they have a relationship doesn't mean that they're actually related. All right, let's do one last one. This one's a little bit more deceptive here. We have the global air temperature change in Celsius. We have this nice graph here. It was made by NASA, which is great. There's this red line on top of it. Looks like the graph is going down. Does anyone know what this red line is called? Usually call it like a line of something. Line of best fit. Good. I need to write this in an actual pencil. Here we go. So this is called a line of best fit. Okay, some people also call it a trend line. Okay, and what it does is it's calculated to follow the graph to like see if the graph is going up in general, going down, staying the same. Okay, what's wrong with this line of best fit? Alec?
It's not accurate.
It's not that accurate because it's the change. That actually might be true. Is it following the graph? If you ignore the red line, is that graph going up or down? The graph looks like it's going up, doesn't it? But the red line, the line of best fit, is going down. So what I suspect this person did is this person just took this graph and then put this random red line on top of it, didn't actually calculate a line of best fit. We'll learn how to do that later. And just stuck this line on top of it to make it look like the graph is going down, when in fact it's actually going up. Okay, so there's a lot of deception in graphs that you see online and things like that. I kind of doubt that the source of this graph is NASA, because usually NASA does a little bit more calculations with the line of best fit, I would expect. But you have to be a little bit careful when you just glance at a graph, because sometimes it's not really shown correctly. All right. Any question on like things that can go wrong in graphs? All right. Now, this basically represents data that hasn't been represented properly to describe what the population is actually doing. We call this bias. Okay, so these graphs are biased. And bias doesn't just happen when we're looking at graphs. Bias also happens when we're going out in the field and doing a survey. So when we're designing the survey, bias can also happen. Now, we have done a lot of talking about like all the different types of questions you can ask in a survey. We mentioned like age. We talked about how you can ask for political opinions, so political affiliation. So this is like age is a number, political affiliation would be a word. We talked about how you can have a free response survey. Okay, there's many different types of questions we can ask. There's all this different type of data that we can be given. Now, along with that type of data, there's also variation in how I can get the data. So there's a variation in a way that I can ask people questions. Just off the top of my head, you can ask people face to face, right? I can go out to the mall and ask a bunch of people questions at the mall. I could pick up my phone and call people, right? I can call people and ask for their opinions. I could do a paper questionnaire, so something paper, maybe send it through the mail, do something like that. The last thing I can think of is maybe like an online forum, right? So I can just go online and ask people to respond to an online questionnaire. All these different types of methods are available to ask questions. And because there's different types of data, there's different types of methods that I can get the data. Some of them are better than others. Okay, so some of them are worse, some of them are better. And some of them lead to this thing called bias, where the way you go about collecting the information favors some answer that doesn't actually represent what the population is doing. Okay, now I have the formal definition of bias. Basically, if you do a survey and it gets the correct answer, it's unbiased. If you do a survey and it's favoring something that isn't the correct answer, it's biased. Let's talk about types of bias. All right, let's go to the page. The first type of bias comes about with something that we've already talked about. Okay, I think maybe it was the first day of class. We talked about this thing called a voluntary response sampling, or voluntary response sample. And this is a type of sampling where you ask people to volunteer their response. Right? So usually radios do that. They'll be like, hey, can we get people to call the radio and give you your opinion on the restaurant? Does anyone remember what the problem was with voluntary response sampling? No? Yeah, like you're gonna get like the opinionated people, right? So if you ask how was the restaurant, you're gonna get really negative reviews normally. You're gonna get very positive reviews, but the people in the middle aren't going to respond. That idea goes with voluntary response bias. So voluntary response bias happens when you have a voluntary response sample. People who are in the middle are just not going to respond. So you'll get the extremes, but no one in the middle. Okay, let's go on to something we haven't talked about, self-interest bias. Self-interest bias is literally in the name. Whenever you have bias where someone is trying to make themselves look good, so they do something weird to make themselves look good. Okay, this happens a lot in commercials. Toilet paper ads do this a lot. Paper towels do this, and like any sort of like cleaning fluid usually does this. This is a sort of, I think this is fake, 'cause I don't think there's a brand called Fairy. I've never seen that, but this one says, okay, our dishwasher fluid Fairy equals 2 of this other fluid, right? Now there's no like results from a sample here. They're just saying 1 equals 2. There's no like scientific thing that's going on here. It's just saying our brand equals 2 of the other. Okay, this is self-interest bias because this company is benefiting from putting out this ad that compares it to this other, right? There's no really science behind it. They're just making something that makes their company look good. All right. Any question on self-interest bias? All right, let's move forward. The next type of bias is very similar to voluntary response bias, and it's called non-response. All right, let me ask you a question. Raise your hand if you committed a crime at 4 p.m. yesterday. Oh, all right. Do you think someone who committed a crime at 4 p.m. yesterday is going to raise their hand? No, right? So non-response bias, an example of this is when some people like literally can't participate unless like they would go to jail, right? So we're missing out people that literally don't have the choice but not to respond because they don't want to say that they committed a crime at 4 p.m. last night. Another example of non-response bias is, what if I called a bunch of people and asked them their response on, do you like cell phones? Who am I missing out with that sample? People who don't have cell phones, right? So people who don't have cell phones literally cannot answer the question, do you have a cell phone? Because they don't have a cell phone, right? So either poorly constructed surveys, like calling people who don't have a phone, is non-response. People won't respond to that you want to respond. And 2, people who can't respond because you're asking them something about something illegal, that's also non-response bias because those people literally can't respond. Okay. I do get one question before all the tests in my past semesters. So I decided to put this question on the notes so you have it. So this question I get all the time is, what is the difference between voluntary response and non-response bias? They both involve people not responding. What's the difference between the two? Mark? Perfect. Literally what I was going to say, right? Voluntary response bias has people not responding, but they choose not to respond, right? They had every chance to respond. They just don't feel like responding. So I'm going to say people, gosh, I can't spell. People choose not to respond. Okay. Now that's different than non-response bias because, well, as Mark said, in non-response bias, people don't have the choice to respond. They're either like doing something illegal and they don't want to say it, so they don't have a choice that way, or they don't have a phone, or they don't have a PO box, or they don't have a mailbox. So they literally cannot respond because they don't have the choice. So people don't have the choice to respond. Okay, so they both involve people not responding, but non-response, people don't have the choice. All right. Any question on these 3 types of bias? All right, we're going to talk about 3 more. They're a little bit different. Let's go on. Social acceptability bias. I think I have a dentist appointment next month. The dentist is going to ask me if I floss every day. I'm going to tell him yes. I'm not going to tell you if I actually floss or I don't floss. But that's kind of the whole idea behind social acceptability bias. when you ask them a question, sometimes someone will respond in a way that they think is the right answer, but it's not actually what they do, okay? For example, a big one with social acceptability bias is voting. A lot of times people underestimate or overestimate how many people vote, because when you go out and ask someone, do you vote? Most of them are just going to say yes. Even if they don't vote, they kind of just lie because they think if they say yes, it's the right answer. So social acceptability bias is when something is socially acceptable to say, and people just say it even though it's not what they actually do. Okay, so that's the whole idea behind social acceptability bias. Okay. Next one that I think is pretty important is leading question bias. Leading question bias is what happens when you ask a question that kind of leads someone in one direction or the other. For example, if I ask someone, how amazing is my class? My class is amazing. Can you tell me how great my class is? Of course, someone's going to respond by like, yeah, your class is great. I love your class, right? Hopefully they'll say that. Now, on the other hand, I could be like, what problems are in Amy's class, right? Amy's got a lot of problems. Can you tell me some of her problems? That's a bad question also, because it's going to lead people to tell, oh, yeah, Amy said she had one brain cell the other day. Like, that's not good. Yeah, so you're leading people into a certain answer. Now, to avoid leading question bias, I like questions that kind of go like this third bullet point, okay? On a scale of 1 to 10, how satisfied were you with our customer service team? That's a good question to ask, because it's not saying, how amazing was our customer service team? Or what problems was going on with that customer service? It's kind of in the middle. It's a neutral question. It's something that isn't leading you on to answer a certain way or not. Okay, so leading questions when you ask a question that's like trying to lead you in one direction. Any questions on the past two biases? All right. The last one, I'm going to put a little X mark by, because I think this bias is kind of dumb. Okay, this is my opinion. This word sampling bias. I'm pretty sure every bias is sampling bias. I don't think anyone calls this sampling bias. So what I'm going to say is, if you see this on the homework and you get marked wrong and points get taken off, just let me know. I will give you your points back. Sampling bias is kind of, I think it overlaps a lot with non-response bias. It says like, oh, if you call people and someone doesn't respond, that's sampling bias. Or if I did something in this way, some people aren't going to respond. That happens a lot with other types of biases too. So I'm including it because it's on the syllabus of this class, but I'm not going to hold you accountable for it if you get it wrong and think it's sampling bias. Okay. Any questions on the types of biases that there are? Alrighty. I think that's the end of these set of notes. What I'm going to do is, I really don't feel like bringing these notes to class next time, so I'm going to pass these out. I didn't actually start them in the next class, so hang tight while I pass these out.